to this presentation on machine learning types, natural language processing, and Python packages in financial machine learning. Now, this course is identified by the code 21 CSE 460, and we will be exploring foundational concept in ML and NLP with a focus on Python's role in financial data science. Our agenda includes four main topics: an introduction to machine learning, types of machine learning, natural language processing, and key Python packages which are used in ML and NLP. Now we will move forward with the introduction part. Now, machine learning is essentially the science of teaching computers to learn from data instead of following a rigid set of program instruction. Imagine training a dog to fetch a ball. You repeatedly show the dog how to fetch by rewarding it when it succeeds. Now, over time, it learns a task, and you don't need to guide it every step of the way. Similarly, in ML, we train a model by feeding it data, rewarding or penalizing it based on its performance, and letting it learn from its mistake. Now, in machine learning, can achieve incredible feats like predicting trends, recognizing patterns in data, and even making decisions. The idea is to create systems that can analyze vast amount of data, learn from them, and use what they have learned to make predictions or decisions when faced with new data. Now, we will move forward with the types of machine learning. Now, machine learning can be broken down into three primary types based on how we teach the model. Like one is supervised learning, second is unsupervised learning, and third is reinforcement learning. Now, what is supervised learning? Now, you can think of it like a teacher guiding a student. We provide the model with labeled data, which means both input data and correct answers are available. Now, the model learns to match input to output. For example, we can imagine a building. Uh, we can imagine building a model which identifies cats and dog in images. Now here, each image would be labeled as either a cat or a dog. When the model sees a labeled dog image, it learns what features make it a dog. Once trained, it can use the learning to identify cats or dogs in new unlabeled images. Now, moving forward, we can talk about let's talk about unsupervised learning. Now, here the model is basically like an explorer without a map. It only has data, but no labels or answers to guide it. The model's goal is to find hidden patterns or groupings in the data. For example, suppose you have a transaction data from a store which shows customer purchase history. By using clustering and unsupervised model, that it can group customers with similar buying habits, helping businesses target customers group or outliers, such as potentially fraudulent transaction. That's one of the major aspects we can talk about in unsupervised learning. Now, moving forward, let's talk about reinforcement learning. Now, this is a trial and error approach where an AI agent learns by interacting with its environment and it receives a feedback. Now, positive feedbacks like rewards encourages the agent to repeat certain actions, while penalties discourages other. For example, let's imagine training an AI agent which to play chess. Like each time it makes a move, it either gets closer to winning or losing. Now, positive reinforcement comes when it makes winning moves, guiding it to play better over time. A popular example of reinforcement learning is AlphaGo, which is basically a model that defeated human champions by continuously learning optimal strategies through practice and feedback. So these are one of the important part where in reinforcement learning comes in handy. Now, moving forward, let's talk about classification regression. Now, in ML, we often use two key techniques, which is classification and regression, to make predictions. Now, classification is about sorting data into categories. Think of it as organizing emails into spam and not spam. Each email belongs in one of these categories, and we train a model to assign them correctly. Now, for example, in a cat versus dog example, which I have taken before, if the model can distinguish between the two, it's solving a classification problem. Now, what do we mean by regression? Now, regression is about predicting a continuous output instead of assigning a category. We are predicting a number, for instance, predicting a house price based on its location, size, and other features. For example, in finance, regression model predicts stock prices based on historical data and other influencing factors. Now, moving forward, let's talk about NLP. Now, NLP stands for natural language processing, and it's the way we teach computer to understand, interpret, and even generate human language. Language, as we know, is incredibly nuanced, with context, slang, items, and subtle variations in meaning. NLP helps bridge the gap between human language and machine understanding, making it essential for applications like chatbot, sentiment analysis, and text translation. For example, in finance, we have sentiment analysis. Using NLP, the financial institutions analyzes news articles, or social media posts to gauge market sentiments. If there is a positive outlook on a particular stock, NLP can help identify this trend, potentially signaling an opportunity for investment. Another example can be taken as fraud detection. Now, NLP scans customer interaction to spot anomalies that might indicate fraudulent behavior, like change in language or unusual patterns in communication that differs from the norm. Now, NLP has a processing pipeline. Now, it involves several steps to convert raw text into a structured format that machine can work with. Now, here's a breakdown of each step with example. Now, tokenization. This is the first step where text is broken into smaller unit called token. For instance, the sentence, the stock market is rising, would be split into individual words. We can say it as the stock is one token, the is one token, stock is another token, market is another token, is another token, rising is another token. Now we have stop words removal. Now common words like the, is, and a don't add much meaning and analysis. So they are removed to reduce noise. We have stemming lemmatization, which is basically words are reduced to their base form. Running, runner, and run all become run so that they are analyzed as the same concept. What is POS tagging? Now we have POS tagging is basically part of speech for each token, such as whether a word is a noun or a verb. We identified the verb, which adds contextual understanding. We have another thing called named entity recognition, NER. Now, NER identifies and categorizes entities like name, place, or dates. For instance, in the sentence, Apple is releasing a new product in 2024. NER would recognize Apple as a company and 2024 as a date. Moving forward, let's talk about Python packages. Now, Python offers several packages that simplify ML and makes it easy to accessible to a broad audience. Now, what is NumPy? NumPy, it's used for handling arrays and complex mathematical operations, essential for most ML tasks. We have Pandas, which allows data manipulation with tables and data frames, making it easy to clean and prepare data. We have Matplotlib, which basically helps us in visualizing data, which is crucial for understanding patterns and model performance. We have SciPy, built on NumPy for scientific calculation, which provides algorithm for optimization, integration, and more. Now, each of these packages plays a critical role in streamlining ML workflows, from preparing data to visualizing the result. Now, in NLP, we have several Python libraries, which makes it easier to work with text data. We have NLTK, like one of the earliest library in NLP. It has comprehensive tool for text processing from tokenization to part of speech tagging. We have Spacey, known for being fast and optimized for production. Spacey is favored for real-time and NLP applications. We have text block as well. It's ideal for simple NLP tasks like sentiment analysis and language translation, providing an intuitive interface for common operations. Now, using these libraries, you can take raw text data, clean and process it, and gain insights, all essential for applications in area like customer feedback analysis or automated response in customer service. Moving forward, in summary, we can say that machine learning offers a powerful set of tools to make sense of data. It comes and automate decisions. With the rise of text data, NLP provides essential technique to analyze human language, and Python packages make both ML and NLP tasks more efficient. We hope this presentation has provided a foundational understanding of how these techniques apply to financial machine learning and beyond. Thank you. Animesh Raj signing off.